So we have seen how to design and how to test a macrostrip line with a specific characteristic impedance. Now, what would be interesting to do is to see what happens when we change the two geometrical dimensions that actually change the impedance of the line. These are the width of the line and the height of the substrate on which it is fabricated. As you may recall, with coaxial lines, we looked at the diameter of the inner conductor and the inner diameter of the outer conductor, and we saw how those affected the impedance of the line. Now we'll do a very similar thing for macrostrip lines, and we'll see how their characteristic impedance is affected when we change the width of the line or the height of its substrate. So just in the same way as we did for the coaxial line, let's create a copy of the schematic by dragging it onto the section heading, circuit schematic, and then we're going to call it macrostrip W sweep, since we're going to sweep the width of the line, and we need to declare a variable. We'll call it WS, and we assign an initial value to this variable, which is arbitrary. We'll just use 1. Then we press Ctrl L, and we fetch a swept variable SWP var and place it on the schematic. This element will allow us to sweep the value of WS, which we will assign to the width of our line, across the range specified. So we need to insert the name of our variable in between the quotes, just here, and then we need to assign a specific range of values to it. So we double click on the element, and then in the value box we can type stepped 1 to 10 in increments of 0.1. We can see now on the schematic that this has created a range of values which starts at 1, finishes at 10, and goes in steps of 0.1. Now we need to assign the variable WS to the element width. Now we can go to graphs and use a similar technique to duplicate the graph. Just drag in the one we've got there onto the section heading, and then we can call this graph macrostrip sweep W. Now we right click on the graph, go to modify measurement. We need to choose the correct data source name. In this case is macrostrip W sweep. The sweep frequency we don't want to use for the x-axis because it's just one value, and so we can just say frequency equals to 1 GHz or just plot all traces. It's equivalent in this case because we've only got one frequency in our frequency range. In terms of the swept variable, what we can do is use it for the x-axis so that we can see Z0 versus W. So we click on OK and then simulate. As you can see, when we increase the width of the line, the characteristic impedance of the line decreases, and that is just the same as increasing the diameter of the inner conductor on a coaxial cable. The more cross-section you give to the current to flow through, in this case the more surface you actually give the current to flow through, the less the impedance. Now what happens if we sweep the height of the substrate instead? Again, we duplicate the schematic by dragging it onto the section heading, and then in this case we'll call this HS. We'll have to keep our width to a fixed value. Let's put it back to what it was before, 2.9. And then we obviously have to choose the correct values for the substrate. So we're going to double click on the element, go back to the range, and change it to something a bit more sensible. We can go between 0.5 and 3 in increments of 0.05. Okay, you can see we've changed that now, so we've got a start value of 0.5 and value of 3 in increments of 0.05. Now we have to assign this variable to the substrate height. So we just put it in here as HS. Let's also rename our schematic so there are no ambiguities there, and we call it microstrip edge sweep. Okay. Now we will duplicate our graph yet again with the same technique. We just drag it onto the section heading graphs, and then we'll rename it sweep edge. And obviously we have to go into the measurement and modify it. In this case, the data source name will be microstrip edge sweep. We want to use the sweep frequency as a fixed frequency, and then we want to use the sweep variable for the x-axis, just as we did in the case of the width. Click OK, and then simulate. Now you can see what's happened. We've increased the height of the substrate. As we increase the height of the substrate, we increase the voltage between the line and the ground plane. And hence, because we increased the voltage and the impedance is the ratio of voltage and current, we've also increased the characteristic impedance of the line, just as in the case of the coaxial line.